Okay, let's look at the homework 2.8 3.1 number 14, right? We have this f of x, which is a rational function, x over x plus 5. And first, we want to find the critical numbers. So let's do that. All right, so in order to find a critical number, we have to take the derivative. So we take the derivative of this function with respect to x. Right, so we have f prime of x is equal to, right, so using the quotient rule, square the denominator, so you have a quantity x plus 5 squared, right? Derivative of the top is 1 times the bottom is quantity x plus 5 minus the top x times the derivative of the bottom, which is 1. All right, so let's see, 1 doesn't really do anything, so I'll erase 1, and here times 1 doesn't do anything. So you can see that it's just going to be x minus x, so you can cancel x and x. So what you get is 5 on top over quantity x plus 5 squared, right? Then notice that the numerator is constant 5, so this quantity is never 0, right? So derivative is never 0. Actually, in fact, it's always positive. You can see that the numerator is, because of the square, it's never negative. You have a positive. So this guy is always positive, right? Then the function, the f prime is not defined when x equals -5, but -5 is not in the domain, so -5 cannot be a critical number. So I guess the answer is does not exist. So the does not exist. D-N-E, right? So have that. Then the open interval of increasing and the decreasing. So, but there's no critical number. But we know that the -5 has to be eliminated from the domain. So you have -5 right here, right? Then you have f prime is going to be, as I said before, f prime is always positive, so it's positive here and a positive there, right? So it's got to be increasing on, so there's increasing on interval from -infinity to -5, right? Then start from -5 to positive infinity, right? Then decreasing interval, there is none, so it does not exist. All right. So the graph of the function looks like this. First, we have to pay attention to the asymptotes. Vertical asymptote of this guy is when x equals -5, it blows up, so it's x equals -5. And also, we can find horizontal asymptotes. You can see that here you have the first power on top and first power on them. So degree on top is 1, degree on the bottom is 1. So we just do leading coefficient, which is 1 on top, and a 1 on the bottom. So y equals 1 over 1. So y equals 1 is the horizontal asymptote. So if you were to sketch the graph, it would look something like this, right? So here is the y-axis, and here's the x-axis, right? Then vertical asymptote is at the -5, so say something like that. So this is vertical asymptote at -5. And a horizontal asymptote is 1. So it should look something like that. So that's 1, right? Then the graph is always increasing. So it's got to look something like this. And then it's going to look something like this. Right? So let's type those in. All right, so we found that there is no critical number, so D, N, E, right? And increasing, so it's going to be negative infinity, infinity to -5. And then you have to use the union and -5 to positive infinity, right? Then right, decreasing, so does not exist. And the graph is going to be, which is that. So let's see, this is decreasing, decreasing, increasing, increasing, but wrong vertical asymptote. And this one, right vertical asymptote, but it's decreasing, decreasing. Here, increasing, right vertical asymptote, and looks like a horizontal asymptote is correct too. So it's got to be this one right here. Right? So let's check. Okay, it came back. Looks like, let's see, we got everything correctly. All right, that's it. I hope that this was clear.